Welcome back, everybody. Today's lesson is 7.4 Applications of Linear Systems. Our objective is that you'll be able to write systems of linear equations. So kind of like we're going to explore word problems and how, if we set up two equations, we can use them to solve the word question. Okay, this slide, you can write notes on the side of this slide or questions, but it's more to talk about the three methods that we've learned and the benefits of them and maybe the negatives too. So graphing is what we started with. Both equations are solved for y. So if both equations are solved for y, it'll be easy to graph. So this is when maybe you might want to graph. Also, if you want to be able to estimate a solution, because sometimes your graphs might not they might not connect at an intersection, so it might be hard to tell the solution. So you can write that down. Substitution, that's when a variable in either equation has a coefficient of 1. In other words, if you have x here and there's no coefficient, you could get it by itself and substitute. Here it is by itself. Or if x is isolated on both of them, then substitution would be a good method to use. Other things, it says both equations are solved for the same variable. That's what I'm talking about here. And then either equation is solved for a variable. So substitution could work in either of these, or it could also work in this one too. Elimination, that's when both equations have the same variable with the same or opposite coefficients. So 2y, 2y, all we need to do is multiply by -1 here, and then we can cancel. A variable term in one equation is a multiple of the corresponding variable term in the other. So in other words, if 3 can go into 6, then this could easily turn into elimination if we wanted it to. Alright, these next couple slides are here to remind us about the number of solutions we might get. So we're going to give the number of solutions. Now one way is we can compare the slopes and the y-intercepts. So if I get y by itself, this first one has y by itself, and it's y equals x minus 4. So our slope is +1. On the second equation, we want to get y by itself. So we're going to take this minus x and we're going to add it to the other side. Here's what that would look like. It would be y equals x plus 3. So if we look, they both have a slope of 1. If both lines have a slope of 1 and they have different intercepts, then we know that they are parallel. So these lines are going to be parallel, and there's going to be no solution. So it's no solution. I want to show you how we could also solve this algebraically. So our first equation was y equals 1x minus 4. Our second equation was, after we solved it, y equals x plus 3. So if we were to solve this by substitution, we would take the first equation, x minus 4, and set it equal to the second equation, x plus 3. Now let's solve this. I want to show you what happens. When I minus x here and I minus x here, it cancels, and look at what's left. We've learned this before. Excuse me. What's left is -4 equals 3. Is that a true statement? No, it's not. And because it's not a true statement, we say no solution. So two ways to discover that this is no solution. Let's practice our method one more time. So our first equation is y equals 3x plus 2. Our second equation, how about we take this y and we'll move it over here by adding it. Okay, so we'll add y to both sides. Then on the second equation we get y equals 3x plus 2. Well, hold on. Whoa, whoa, whoa. These are the exact same equation. So remember, if that happens, we say infinite solutions. That it's basically the same line. Now, what would it look like if we did it the other way? Well, we would take the black equation and say 3x plus 2 equals 3x plus 2, and we would minus 3x from both sides. Again, our variables disappear, but this time what's left is 2 equals 2, and that's true. 2 does equal itself. Then we say infinite solutions. All right, so now we have some word problems that I wanted to practice before you do your packet. Just so you can see them ahead of time and ask any questions you might have. Mr. Deems is older than Miss Senny. The difference of their ages is 2. The sum of their ages is 62. Find the age of Mr. Deems and Miss Senny. Now, on these, you have to set up a system of equations. You have to write 2 equations and solve them by graphing, substitution, or elimination. The first thing I do is assign variables. I'm going to say Mr. Deems is X and Miss Senny will be Y. Then I'm going to write my equation. So the difference of their ages is 2. So we will do Y minus X equals 2. Please note that I'm kind of guessing that Miss Senny is older than Mr. Deems. I'm not sure. The difference of their ages is 2. Now the sum of their ages is 62. Well, sum means to add. So Y plus X equals 62. Well, if you look at these 2 equations that I set up, it's ready for elimination because these are opposite. These are opposite, so they're going to cancel. So Y plus Y is 2Y. My x's cancel to 0, so I'm just going to ignore them. And then 2 plus 62 is 64. So next, I divide both sides by 2. Then I get y equals 32. So I have to go back, and I have to see who that is. So Mrs. Senny, she is 32. And then all I have to do is plug that 32 into one of my equations. So I'll do the y minus x equation. So I'll do 32 minus x equals 2. Alright, so here's what I ended up with. I minus 32 from both sides, and I had a negative x equals negative 30. So positive x must equal 30. So Mr. D, not me, but Mr. Deems is 30. So Miss Senny is 32 and Mr. Deems is 30. Okay, we've done problems like this one in the past. The sum of 2 numbers is 39. The difference is 7. What are the 2 numbers? So we just have to define our variables. Well, x will stand for the first number and y will stand for the second number, but it doesn't really matter. So we can just say x and y stand for our numbers. So now we have to do our first equation. Our first equation is the sum. So x plus y equals 39. My second equation will be, it said the second equation involves a subtraction, the difference. Their difference is 7. So I really don't know which one's bigger, but I'm just going to do x minus y equals 7. All right? If I look at this equation, or the system of equations, it looks like it's ready for elimination because I have a positive y and a negative y. So what I'm going to do is just add going down, and I get 2x. 1x plus 1x is 2x. This cancels, and then I have 39 plus 7 is 46. So my next step is to divide both sides by 2. So if I divide both sides by 2, x equals 23. Okay, I have half my answer done. So one answer is 23. I need to go back and get my other answer. Well, I can use this equation right here, even though I crossed it out. This equation is, well, actually, I'm going to use the top equation. The top equation is x plus y equals 39. So remember, we're going to substitute in our 23 and put it where x is. So I'm going to write a 23 right here. I'll do 23 23 plus y equals 39. So next, I subtract 23 from both sides, and I get 16. Y equals 16. So there's my answer. 23 is x, and y is 16. Okay, so this is our last word problem before the practice problem. We've done a question like this before, but we're going to learn a new way to do it using systems of equations. The question reads as follows. I want to make the perfect cherry soda. Wild cherry Pepsi is made with 20% grenadine mix, but cherry Coke is made with 15% grenadine mix. A perfect cherry soda has a 16% grenadine mix. What do I do if I want to make a 12-ounce soda that has this 16% mix? So what I'm going to do is set up a table with you and show you how to solve this. So the way I set this up was I did my percent that's grenadine, the ounces, and this would be the total ounces of pop. And then this would be how many of those ounces are just pure grenadine. So the grenadine ounces of grenadine. Let's start filling this in by looking at cherry Pepsi. Cherry Pepsi has what percent grenadine? 20%. So fill this in with me. 20%, which is 0.20. Do we know how many ounces our cherry Pepsi is? No, we don't know how many we're going to have to pour. So I'm going to use the variable x. Then the way I find my amount of grenadine is I take 20% multiplied to how many ounces I have. So 0.20 multiplied to x. It looks like this. 0.2x. Next, I need to do cherry Coke. Cherry Coke is 15%, so I'm going to fill that in right here. 0.15. And instead of x, I'm going to say y because it's a different kind of soda. And just like I did above, I'm going to multiply those together. Lastly, I call the last column the final column because my final soda, my 12-ounce soda, needs to go here. Now, what percent do I want that to be? Let's see. The perfect soda is 16. So what I'm going to do is I'm going to write 0.16 right here. And how many ounces do I need? I need 12 ounces. So I'm going to write that right here. That's ounces. And I'm going to get a calculator, and I'm going to multiply this to 12 to find out how many ounces of grenadine will actually be in that final soda. Well, the answer is 1.92 ounces. So I made the table, and I encourage you to make a table on these types of questions to help you. So once you have the table, you're going to write an equation for this column and for this column. Here's what it looks like. The first column will look like this. X plus y will equal 12 ounces because if you pour both of your sodas together, you only want 12 ounces when you're done. The second equation will look like this. 0.2x, so 0.2x plus 0.15y will equal a volume of 1.92. So 1.92 ounces will be all grenadine. Again, here are my two equations. All we have to do now is solve this. So we're going to do systems of equations. I suggest substitution. So I'm going to take this equation and get y by itself. What I did was I took the x, which was positive, and I minused it from the 12. It looks like this. Y equals 12 minus x. So I'm going to substitute in this 12 minus x and write it right here. Here's what it looks like. So, yes, I took the 12 minus x and I put it right here where the y was. So now all I have to do is distribute and combine like terms and solve this. Now I'm going to combine my like terms. I'll take the 0.2x and minus 0.15x from it. Okay, so I did that and I got 0.05x. Now I'm going to minus this and divide by 0.05. Okay, so I ended up with, after I divided, 2.4 ounces, and I had to go back and look. X is cherry Pepsi. So if I know that 2.4 ounces is cherry Pepsi, all I have to do is minus that from 12. So all I have to do is just go 12 minus 2.4, because then that means that the Coke, the cherry Coke, will be what's left. So cherry Coke will be, all right, so the cherry Coke will be 9.6 ounces. So my final answer is mix 2.4 ounces of cherry Pepsi with 9.6 ounces of cherry Coke, and you'll end up with 12 ounces of 16% grenadine, and in that 12 ounces, 1.92 will be all pure grenadine.
Okay, everybody, here's your practice problems. Write and solve a system of equations. This isn't Matthew.